All right. Welcome, ladies and gentlemen, to another wonderful lesson with Mr. Wheezy. Aren't you guys loving this? I know you miss me. So, starting with our kickoff here. What does SOHCAHTOA stand for? Well, so is sine, opposite, hypotenuse. So sine is opposite over hypotenuse. Ka, cosine, adjacent, hypotenuse. And lastly, toa, tangent, opposite, adjacent. So SOHCAHTOA. So sine opposite over hypotenuse, ka, cosine adjacent over hypotenuse, and toa, tangent opposite over adjacent. Ways to help you set up those trig functions. But we're going to moving on. Last time we looked at just right angle trig. So what were those important angles? So 30, 60, 90, 45, what's going on at all those different angles, those main angles. Well, now we're going to be getting into, well, what happens at those other angles? Because we could do really any angle with this. So, pretty much R is going to be your radius. So whatever your x is of the point where you're at, making that angle going around the circle, x squared plus y squared, if you square it, you get your R. Guess what? Pythagorean theorem, right there. That's where that's coming from. So think in the past, we always just did sine is the y, cosine is the x, tangent is y over x. Well, tangent and cotangent aren't going to change. Reason why these were y over x is it's really y over r, the radius. Well, in the unit circle, our radius is 1. So y over 1 is just going to be y. That's where that's really coming from. But what we're doing here is you're just going to take whatever the y value is, put over the radius of that. Same thing here, only it's x over the radius, and then flip those over here. Tangent, cotangent stay as x over y. On cotangent and tangent, y over x. So, where we can do this stuff. Here we have P is going to be -3, -5. So that's a point on the terminal side of our angle. So terminal side is where that angle ends. We always line up the initial side where it starts on that y-axis at 0 degrees. So if we're here, we'd always start at this point, this here axis on our circle as we're going around. Terminal side is at -3, -5, so it's going to be leaning somewhere over here, so that we're at -3, -5. So before we would just go, okay, we're going to put, I am sorry, I am off the screen. That is my bad. So we're going to be over here. Now, normally we're using the unit circle, at least in the last lesson we were. So our radius was always going to be 1. Here our radius is going to be something different. So we have to check that, we have to find that. So if we make our right triangle here so we can do our trig. So I'm just going to move this down here. So we're -5 down, and we'd be -3 across. So I kind of have the triangle drawn wrong, and I'm sorry. So -3 is the x, -5 is the y. We have to find what r is here. To find r, we're going to do -3 squared plus -5 squared, all square rooted. Now, in your calculator, make sure you put parentheses around this, because otherwise it's going to go -3 squared is, well, 3 squared is 9, and it's negative, so -9. It's going to give you the wrong answer. So put that in parentheses, because when you square a number, the negatives should cancel out. When you do that, well, this is going to be 9, this is going to be 25, which ends up square root of 34. Now, that doesn't come out real nice. We're just going to leave it as square root of 34. So that is r. So that's what we can use there. So sine is still the y over the r. So our y value is -5 over the square root of 34. Again, we don't like that. We would rationalize it. So times by the square root of 34. So we end up with -5 square root of 34 over 34. Cosine x over r, we're going to run into the same thing. So cosine is the x, so -3 over your square root of 34. Again, rationalize that, so you get -3 square root of 34 over 34. Tangent though is still just x over y, or y over x, sorry, y over x. So negative 5 over negative 3, the negatives are going to cancel, you end up with 5/3. Remember, these are just flipped over on this side. So negative 5 over the square root of 34 becomes the square root of 34 over negative 5. Here, negative 3 over 34, again flip, square root of 34 over negative 3. Now, you may say, why does the negative go to the bottom? Really, the negative can go either way. Really, it should probably be out front here. But just know the negative can either be on top or on the bottom or out front. You have options there. And lastly, flip this over, so 3 over 5. And that one's done. Now, we're not completely ditching the unit circle, but we're going to expand it a little bit here. We're not just going to focus up to 90, but we're going to go all the way around to 270. Now, keep in mind, 0 degrees, still going to be the same thing as 360. So just know it repeats after we get back to here. So quarter circle, half a circle, 3/4 circle, you'd be back to a full. And then you'd repeat if you want to keep going around with your angles. But we're going to look at sine and cosine of these. So sine, actually tangent, sorry. So if I draw my unit circle here, this would be 0, 90, 180, 270. Well, our point that right here is at 1, 0. Here we would be at 0, 1. This here would be at -1, 0. And this one here would be at 0, -1. So that's just the points that we would be at here. We're at a radius of 1, so we're 1 this way. Well, here we're not going up and down at all, so we have 0 on the y. Here we're just going 1 up, but not left and right, so 0 on the x. Here we've gone left, so it makes a negative x. Gone down, so negative y. That's where those are all coming from. So if we want to think about it, sine is your y over r. Tangent is y over x. So like on 0 degrees here, we would be 0 over our radius of 1, because that's r here, which is 1. So with 0, we're at 0 over 1, which is just 0. Tangent-wise, y, because remember we're always x, y. Y is 0, x is 1. This is 0 over 1, which is 0 as well. At 90 now, y is 1, our radius is 1, so really 1 over 1, so there's 1. Tangent though, y over x is 1 over 0, which means it's undefined. We can't divide by 0. Can't do that one. 180, right here. So y is 0, so 0 over 1, which is 0. For tangent, y over x, 0 over -1 is 0. Lastly, 270, so straight down. Keep in mind these are in radians, so 90 is pi over 2, 180 is pi, 270 is 3 pi over 2. That's just the radian measure. But if we do sine here, sine we're dealing with the y, which is -1 over 1, our radius. So we get -1 for that one. Tangent then, -1 over 0, so again, undefined. So that's where those trig functions are going to be on those. Now, if you put them in your calculator, you get the same thing. You could do sine of 90 if you're in degrees, and you're going to get 1. That's just where that's all coming from. This is just another way that we can find what those values are. Now, something you may have noticed there. Our trig functions are going to be different signs based off of the quadrant you're in. When we were down at the bottom, our y's were negative. That made sine then become negative. So same kind of thing is going here. So quadrants 1 and 3, all 6 trig functions are positive. I feel like that's not quite right. So let's map this out. We have some room up here. So if we look at sine, let's go cosine and tangent. This is when we're negative. It's going to be when we're positive. Remember, sine goes with cosecant, cosine goes with secant, tangent goes with cotangent. Those are all going to be tied together. So if we look at quadrant 1, so on our graph here, quadrant 1, we're positive, positive. Here we're going to be negative, positive, negative, negative, and positive, negative, as far as our sign goes for order of pair. So in quadrant 1, everything is positive, positive. So all these are going to be positive in 1. Let me draw this across. So 1, 1. Now, in quadrant 2 here, x is negative. So what affects x? Well, keep in mind, sine is the y, cosine is the x, tangent is y over x. So our y's are going to be positive. So anything involving y will be positive there too. So quadrant 2, sine and cosecant will both be positive. However, cosine, tangent, and along with those secant and cotangent, they're dealing with an x. So in quadrant 2, those are going to be negative because our x is negative. So that's going to make that, that's going to change that problem. And I believe this is what's really dealing here, but it's just, for me, words don't always put it together. I need to make a chart sometimes, and then I can visualize it a little better. If we go to quadrant 3, so here, sine the y would be negative. The x is also negative. So in this case, that's going to make sine negative. So yeah, so this one here, 1 and 3, that is a typo. I don't think that should be the case. But y is going to be negative. Just x, again, our radius is always going to be positive. So that would make this one here be negative as well. However, for y over x, they're both negative. Negative over negative makes it positive. That makes these three, or these two, tangent, cotangent, positive in quadrant 3. And so lastly, then quadrant 4, x is positive, so anything involving an x here. So IV for 4, which is just cosine. The y, though, is negative. So this one will be negative in quadrant 4. Tangent is y over x. Again, one is positive, one is negative. Makes this be negative then. So that's where we're going to be positive and negative at, which I think there's a graph or a little chart later on that tells you exactly where's where. Yeah, later on in the notes, there's a little thing here that's got this. So if you think quadrant 1, they're all positive, all were positive in quadrant 1. Quadrant 2 is just sine and cosecant, that's positive. That's the only two. The rest of these were negative. Tangent, cotangent, positive. So that was the only 3 that was on this side. These both had 3s over here where they were negative. Cosine, secant, positive. So this is another way that's representing this chart. So where this comes into play is problems like this. So what quadrant is it if tangent is negative and cosine is positive? So we come up here, okay, tangent negative. We gotta be in 1 and 2. We also know cosine's positive, so between 1 and 2, where is cosine positive? Or I mean 2 and 4. Well, 4 it's positive, so we have to be in 4. So that's kind of where we can do this. So look at, okay, where's the first condition met? Tangent being negative in 2 and 4. Okay, where's cosine positive? Well, it's in 1 and 4. Where are they overlapping? Well, they overlap in 4. That's how we get that. So you're going to have some that are like that. You're also going to get some like this. Given that tangent is negative 2/3 and cosine is greater than 0, find cosine and cosecant. Okay? So, tangent. First I'll remember is y over x. So this is where we go, okay, well, y then has to be 2, x then has to be 3, but which one gets the negative? Well, if cosine is positive, cosine is the x. That means the x has to be positive, so the y then has to be the negative part of this. So cosine Well, cosine is x over r. So we know we have the 3. We're going to have to find what r is. Cosecant, same thing as sine but flipped. So if sine was y over r, this would make this r over y. So again, we have the y, which is -2. So in order to finish this out, we have to find what r is. To find r, we're just taking x squared plus y squared square rooted. So x is 3 squared plus y of -2 squared. This would be 9 plus 4. This would end up being the square root of 13. So we could do square root of 13 here. Square root of 13 over here. So cosine square root of 13 over 2, -2. And that would be done. Here we'd rationalize. And so we'd get 3 square root of 13 over 13. And that's how we find those. So use that knowledge of what quadrants are we positive, what quadrants are we negative for each trig function, and then we can answer questions like each of these. Find out which quadrant matches up. Here, because we know cosine is greater than 0, well, if cosine is greater than 0, we know that's our x, so the x has to be positive. That makes the y be negative in order to get a negative tangent. Okay. So, trig functions really do operate from 0 to 90, or 0 to pi over 2. They're in that little corner. Well, what happens when we get to bigger angles? Well, that's where we're going to use reference angles. Reference angles are just going to be how far away are we from that x-axis, so that we get an angle that's between 0 and 90. So like here, if we're over here in the second quadrant, how much short are we from 180? That's going to be our reference angle. Third quadrant, well, how far past 180 are we? Fourth quadrant, how far away from 360 are we? How much short are we? So we're going to use that then. So our first one here from quadrant 2, you're going to take 180 minus whatever our angle is, and that'll give you a reference angle. Here you're going to take a reference angle, or angle minus our 180 to get a reference angle, and 360 minus our angle. So let's just find reference angles first. So 345, that's going to be in quadrant 4. So we're going to do 360 minus 345, and we would get a 15-degree angle. So that would be our reference angle, which reference angle, they write it theta with a little apostrophe, so you know it's a reference angle and not the actual angle. Angle, just theta. So here, 5 pi over 6. If you think about it, 180 is pi. So for 5/6 of pi, we're really close to being pi. And so we would take pi minus 5 pi over 6. Well, to put this over 6, we would take the top times 6. So you end up with just a pi over 6 for our reference angle. So there, think, what would make that a whole? Well, 1 more 6. Negative 135. Now, same thing here. Even though we're dealing with negatives, we're still not in that first quadrant, because negative 135, we're rotating down 135. That's going to actually put us in quadrant 3. So when we rotate, we go 90, we'd be over here somewhere. So we're still going to go, okay, how far to that x-axis? So to 180. So if we take 180 minus our 135, we're going to end up with 45 as a reference angle. So we're just 45 degrees to getting back to our x-axis here. Away. So 2.5. You're probably going, okay. 2.5, since there isn't a degree symbol, that means this is radians. That's kind of your clue right there. So radians, no degree symbol, degrees have a degree symbol. Look for that there. So if you think about it, 2.5, you're probably going, I have no idea where 2.5 is on quadrant-wise. Fair enough. But let's look at this. Pi is 3.14. Well, if 180 is pi, our deal, this here would be at 3.14 radians, going around to there. So if you think about it, 2.5, 3.14, not too far off. We're going to be somewhere in this third or second quadrant here. So that's what we're going to do. We're going to do pi minus 2.5, and when you do that, you're going to end up, which again, this is 3.14. It's going to be roughly 0.64 that you're going to get for a reference angle. Not going to be a whole lot of them like that, but just so you have an idea of what could be. So reference angles also work when we're more than one revolution. So when we're greater than 360 or 2 pi. So we could still find that reference angle, but we're going to have to take out those revolutions first. So like here, 580. We know we're bigger than one revolution. So let's take that 360 out. So 0, 20, 220. So now we know, okay, 220. Now we know where that's going to be at on our graph. 220, we're at 90, 180. We're going to be somewhere over here. So how far is it back to the x-axis? Well, 220 minus your 180. We end up with 40 degrees for a reference angle. So get rid of those revolutions. Let's get it down to 0 to 360 or 0 to 2 pi if we're in radians. Let's at least get to where we know we can work with. Then we can go from there. Okay, well, where does this fit? Okay, we need to get this back to that x-axis. So we're going to add 180, subtract 180, whatever we got to do. So 8 pi over 3. First off, 2 pi, if we compare it to be, get into like denominators there, if we put it over 3, well, 3 times 1 would be 3, so 2 pi times 3 would be 6 pi. So looking at this, definitely more than 6 pi, so let's get rid of that revolution. So if we minus out 6 pi over 3, we'd be left with 2 pi over 3. So think about it, 2 pi over 3, think we're 2/3 of the way to pi. So we have to be in here somewhere. Well, how much short are we? Pi over 3 short. Makes our reference angle. Okay, same thing here. So 2 pi is going to be what with the denominator is 6? Well, if I take 1 times 6, 2 times 6 would be 12 pi. So we're more than one revolution, however we're backwards. So we're just going to add this 12 pi over 6 in to try and get back into this. 13 and 12, we're going to end up with a negative pi over 6. That one's simple. That's going to be your reference angle. Actually, hold on. Our reference angle is just going to be the positive pi over 6. Because if you think about it, at negative pi over 6, we're down that far. So, well, how far back? Well, a pi over 6 back. So that's where that's coming from. So reference angles can be used then to evaluate trigonometric functions. The trigonometric function of any angle will be the same as its reference angle with the possibility of a sign flip. So what's that saying is we can go ahead and find an angle bigger than 1 or bigger than 90 for a trig function. But what we're going to do is we're going to use its reference angle. Now, tangent of 120, if we draw this out, 120 is going to be over here somewhere. So we're in the second quadrant. In the second quadrant, we know that tangent is negative. That's why they put the negative in front. And we're also going to have to find that reference angle down to here, which, well, if we're at 120, we're going to be 60 short. So they're going to do tangent of 60. Well, we know tangent of 60 is square root of 3. That's something we did in that last lesson. But because we're doing reference angles, we know tangent is negative in that quadrant, so that makes a negative square root of 3. So it's a way to help us find these angles when they're bigger than 0 to 90. So, tangent of 120, know it's here in the second quadrant, that makes the tangent negative. Our reference angle then, 120 is 60 short of 180, so that's our reference angle. 60, well, tangent of 60 is square root of 3, but it was negative being in the second quadrant. That's why it's negative square root of 3. So we found that without even using our calculator. So when we're doing reference angles, first off, find that reference angle. Then you go through and you can find, okay, well, what's the trig function? What's that value for that reference angle? And then lastly, think about your quadrant. Well, if we're in quadrant 2, tangent's negative, so I got to put a negative for that value. So, sine of 135. Again, 135, we don't have an angle for sine that works that way. So we're going to look for the reference angle. 135, we're going to be past 90, not quite to 180, so we're in the second quadrant. So how far short of 180 are we? Well, 180 minus 135 leaves us with 45. So what we're really going to do is sine of 45 degrees. Now, sine, are we positive or negative in this first and in the second quadrant? I mean, we know everything's positive in the first, but in the second, we're above, so sine is going to be positive. So we're just going to leave sine of 45. Sine of 45 we know is square root of 2 over 2. Okay. Cosine of 4 pi over 3. Well, start 4/3. If we think of this as 4/3 pi, well, we're going to be more than 1 pi, but closer to 1 pi than we are 2 pi, so we're going to be here in this third quadrant somewhere. So how far past are we? Well, pi would be 3 over 3, so for 4/3 we're 1/3 past, so we're pi over 3 past. Now, cosine, negative in this quadrant, because we're on the left side of the y-axis. So that'll make this whole thing be negative here. Now, cosine of pi over 3 is a half. Because it's negative out front, we're going to end up with a negative 1/2. Again, getting this stuff from previous lessons as far as what these values are. We already went through and we solved for those. At the end of the lesson too, besides this little handy dandy chart, I give you this here, which has these special angles, your 30, 45, 60, so pi over 6, pi over 4, and pi over 3, what those are at each of these trig functions. So you can always look there too to help you out. Cotangent of negative pi over 3. So negative pi over 3, we're going to be down here. Well, we're rotating a pi over 3 down, so that's how far off of our x-axis we are. So this will still be cotangent of pi over 3. Cotangent in the fourth quadrant is negative. So we're going to put the negative in front here. Now, keep in mind, cotangent is really 1 over tan. So that's where we can come here and go, oh, hey, tangent at pi over 3 is square root of 3. However, we're going to be flipped since we're cotangent. So that means we're going to be at negative 1 over the square root of 3, the negative from in front. Rationalize that to get your square root of 3 over 3, but it's negative. So that's kind of how this is going to flow. We got a little bit left here. Works the same way for when we're over the 360. Kind of what we did just a little bit ago. When we're bigger than 1 revolution, we're going to take those revolutions out, and we're going to use that to find a reference angle. So 2 pi, if we convert over to a common denominator of 3. Well, 1 times 3, so 2 pi times 3 is 6 pi. Is 1 revolution. So if we take a revolution out, let's go 14 pi over 3. So take away a 6 pi over 3, we're left with 8 pi over 3. We're still not in 1 revolution. So we can take another revolution out. So let's take out another 6 pi over 3. Okay, so now we're down to that single revolution. We're between 0 and 2 pi. Now we can do our, this is going to be, we can find our reference angle from here. So pretty much what this did is if we started here, we would go around and then some to get to our deal. Now, 2/3 of pi, we're going to be past halfway. So we're going to be past pi over 2, but not quite to pi. So we'd be here in that second quadrant. So we're going to be finding tangent. So in this, how much short of pi are we? Well, for 2/3 there, we're just 1/3 short. So pi over 3. Tangent in that second quadrant is going to be negative, so we put a negative in front. So again, looking at our little chart, at pi over 3, tangent is square root of 3, but it's negative, so negative square root of 3 would be our answer. Again, doing all this without using a calculator. Okay, so now we're over 4. So 2 pi over 1 would be what when we put it over 4, when we find that common denominator? Well, we're going to have to take it times 4, so 8 pi. We're negative, so to get back, we're going to have to add those revolutions back in. So 17 pi over 4, and we're going to add in 8 pi over 4. That 17 is negative. 17 and 8 will leave you with 9 pi over 4. Still bigger, and we're still negative. So add in another one. This is something we could keep doing until we get to where we're down to it. Maybe it's 1 revolution, maybe it's 10 revolutions. Just keep doing it until you're within 1 revolution. So you end up with a negative pi over 4. So again, negative, we rotate down, so it'd be here. So if you think about it, we're down a pi over 4, so that means we're a pi over 4 short of our 360 or 2 pi. So we're going to do secant of pi over 4. Now we're in quadrant 4. Secant in quadrant 4 is actually positive, so we're just going to leave this. Secant now, remember, is 1 over sine. So if we do sine of pi over 4, we're going to get square root of 2 over 2. So we're going to flip that and have 2 over the square root of 2. You'll rationalize that. So take a times square root of 2, square root of 2. So 2 square root of 2 over 2. Well, our 2's can cancel out. We just end up with square root of 2 then. And that's it for this lesson. So, again, questions, comments, concerns, please send me a message on Google Classroom. Pan me, although remember, I'm not as quick to answer your pans. I don't check that as often. Or email me. Email me works pretty good. From here, we're kind of going to skip around a little bit. We're going to skip over the next two because it's just graphing these trig functions. And it's something that takes a little bit of time and is kind of confusing. And I'm going to skip over just to avoid that, being we're doing all online and I can't be there to really work through it with you. So we're going to skip over those. We're going to hit 4.7 and 4.8. And then we're going to skip over chapter 5. Chapter 5 is proving trig ratios, trig functions, sort of a thing. The identities. So how do all those work? Again, we're going to skip over those because it's one of those that's a little more confusing, and it's a lot better if we can just work through those together as a class. So because we're online, we're going to skip over those. But I do want to hit law of sines, law of cosines for the juniors, especially if you're going to take physics next year. They use that there. So we're going to use that to wrap this up. So we're almost there, guys. Hang in there. But until next time, we'll talk to you later.